Alright, so I'm going to do the second problem on Module 9, Lesson 3 here. So what we have going on is we have a SeeSaw, which is a playground toy that almost doesn't exist anymore because these things are stinking dangerous. But there's a pivot point here in the middle, fulcrum, something of that nature. So we have a child of mass 20 kilograms in one spot. And, oh yeah, okay, I see the trickery that's going to go on here. Okay, so that 20 kilogram kid is going, yeah. All right. $20 kilogram kid's going to chill out there. The 30 kilogram kid, in order to balance, you think about this torque thing, the 30 kilogram kid is going to have to be closer because the 30 kilogram kid will exert a greater force. So in order to balance torque, which causes rotation of the seesaw, the greater force will have to be exerted at a lesser distance because torque equals force times distance or force times radius of application of the torque. So that's what I'm going to do here is I'm just going to draw this thing, and I have a suspicion about the ratio of the distances here since this is a 2 to 3 ratio of mass, but we'll see if my suspicion is correct. I'm kind of feeling like it might end up being a 2 to 3 ratio, but we'll see. We'll see what happens. 30 kilograms. There's the 30 kilogram kid. Now, what that means practically is that this force, that's gravity. Let's call this kid B, and we'll call the other kid A, just for reference. So weight of B is 30 kilograms times 9.8 meters per second squared. And weight of A is going to be less. All right, so weight of A is going to be 20 times 9.8 meters per second squared. So I think that's going to be 196. Yep. And this one, you know what, that ends up canceling out anyway. I shouldn't have gone this far, but it'll be fine. You really only need the masses, and if you just set the equation up, the masses cancel out in the equation. But nonetheless, here we go. So that one will be 294 newtons. All right. Now, the definition of the coordinate system is kind of important here. So the thing that we want to know is what distance from the pivot point is the child sitting. So we're going to call that distance D. Why not? You could call it X or Y or something else, but I like D for that. Now, the other thing that we were told is that the children are 3 meters apart total. Now, let's go over here and set up our balanced torque equation because we know that the torques must be balanced because the children are sitting balanced, so there is no angular acceleration here. So sigma tau, sigma of torque sum is equal to 0, and that's because there are two, well, in this case two, but all the torques sum up to 0. So the torque of child A plus the torque of child B is going to add up to 0. And that also, well, let's just go ahead and do this. Okay, torque of child A is going to be weight of child A times D. And this is probably the trick. If I was going to guess where you're getting hung up on this problem, it's probably this. So weight of child B. And here's the deal. The distance child B is from the center is going to be this, which is 3 meters minus D. Okay. And let's see. I think that we probably need to say that something is negative here because these guys will end up being equal in size. But anyways, I'm gonna say this is negative because this one, the distance from the pivot point is to the left, so we'll make that one negative. All right, so long story short, move this over. Do I need to move this over to the other side? Yeah, I think so. No, I'm not gonna move that yet. Let's do some algebra. Plus, I'm going to distribute here first. All right, so I think what we want to happen here is we want to get all of the D's on the same side, so I'm going to move 3WB over to the other side. So I just subtracted it from both sides to get it moved over to the other side. That's going to leave a negative WAD minus WBD. And now I have the D isolated on this side. Also, if we divide everybody, all the terms by -1, they will all become positives, which is slightly easier. Now I'm going to factor out the D plus WB. And that still equals 3WB. And then we're going to divide both sides by A plus B. All right, so algebra completed. Well, sort of. Let's plug in some numbers and see what happens here. So 3 WB 294 newtons over 196 newtons plus 294 newtons. All right, so all told, that comes out to 1.8 meters. Yeah, I left off the meters here. There's a meters in there. Okay. Anyways, so that is our distance. Let's see if that makes sense. So if D is 1.8, then the other child, the 30 kilogram child, would be 1.2 meters. That's 3 minus 1.8 is 1.2. And I think that matches the original prediction that there would be a 2/3 ratio there because 1.2 is 2/3 of 1.8. So yeah, that makes sense. The smaller child's farther away and the bigger child is closer. Hope that helps.